You with him today again, Andrew?
Yes. Correct. Yeah, we need to wait for Jacob so I can figure out if they need that grapple or not. Morning, Jaron. Don't forget to clock in. What are those?
Oh, it's out. It's free. It's free out.
So you have anything to do?
I just don't want to grind it. You don't want to grind it.
Hey, do you need the grapple?
Last day.
That's it. Okay.
But the stumps, it's staying down there for the stump grinding.
What's up, Linda? Morning. Okay.
To my knowledge.
All right. So you'll need Darren today. Okay. All right. Yeah, you're going down. Ha! You stay.
There's no oxygen in there.
What?
I mean, once I laid there in bed for a while, it was pretty. I don't know. I was tired. Yesterday I was suffering. Well, so on Saturday and Sunday, I didn't get a lot of sleep. Night before last night, I didn't get a lot of sleep. I might have just
Maybe you're cheating or something. You never know.
All right. Good morning, everybody. Happy Tuesday. We'll go ahead and begin. We're missing a couple people, but that's all right. We can press on to recap. So, all right. So 3-strand. We'll do a quick recap. 3-strand. Give me some pros and cons of it, Mr. Collin.
Cons is it tries to unwind the load,
Okay.
and pro is it has those bumps.
Less.
Lesser.
Yeah. So abrasion. Okay. Who remembers what that term is as far as it wants to unwind? Mr. Brian? Yoshida?
Oh, okay,
Unbalanced.
Are you playing charades?
We're playing charades, yeah. Let me give you some clues. Balanced and unbalanced, right? So it's a balance. So 3-strand is unbalanced, right? It's going to want to unwind, okay? 16 strand. Pros and cons, Mr. Allen?
It's good stuff.
Good stuff, okay. Yeah.
Oh, you can.
With after work.
Drawing blanks.
Help them out, Ken.
It's gonna be easier to like work with. It's gonna be a little bit better in the sun, right?
Over 3-strand? Or some pros of it? Okay. Well, I guess. All right. Well, compared to Aramid and the HMPE. Okay. Miss Linda, you got anything? It is balanced. Okay. Very good. Cool. Yep. That's perfect, right? Balance. It is a little stronger, right? Because of the braiding effect that happens to it. Is the core, if it has one, is the core part of the strength? Jared?
No.
No. Okay. What's the purpose of the core if it has one? Do you know, Janessa?
Sorry, this is for what's the outer?
So that we're doing 16 strand.
16 strand?
Mm-hmm. What's the purpose of the core if it does have one?
And it doesn't help with strength.
Correct.
Is it because it's like more expensive to have a rope made of? Does it depend on the material, I guess?
Negative. So
Shape.
holds its shape better, right? So it keeps it rounded, more rounded under load. Right? It'll keep the shape rounded under load. Okay, cool. 24 strand. What are the two types what two classes are there of 24 strand double braids? One? Later. You don't remember? Two types of classes.
Class 1 and class 2.
All right, Dale. Good job. Class 1, class 2. Very good. Kind of gave it away there, right? All right. So what's the difference? What is the difference between a class 1 and a class 2 double braid? Andrew?
Is class 1 the one that's not core dependent?
That is correct. Okay. Class 1 is not core dependent. Class 2s are core dependent.
What do you mean by dependent?
So the class 1s, right, so that they're not core dependent, that means they cover in the core, share the load, right? So 24 strand is going to be a 60-40, 50-50. Rarely does it get down to like 30-70, but the cover and the core are going to share the load, right? Class 2 is core dependent, so the core is 100% going to is going to be the strength of the core is what's going to hold the load. Okay.
So what's the core?
What's that?
What is the core?
The core, like we talked about last week, right, is going to be different types of fibers, right? Your aramids, your HMPE, high molecular polyethylenes, right, are going to be in the core. They're going to be a lot stronger, have less elasticity, higher abrasion resistant, higher heat resistant to it. Okay. So if that's the case, right, why does a class 2, if the aramids and the HMPEs, if they're high strength, they're high heat resistant, why are they double braids? Why not just be a 12 strand hollow braid? It's one of their big flaws. You guys remember? They are expensive. Yep, they're very expensive. Okay, so protecting them for longevity. Okay, but something a little more crucial than that. Does anybody remember? Not the elongation. That's why they are important for the applications they have. Janessa?
UV protection.
UV protection. Okay, that's their Achilles heel, right? If they are exposed to the sun, they degrade and degrade quickly, and they become crystal. And I thought of it last night because I was dreaming about this. My analogy for how the fibers form is like cotton candy. Okay, so cotton candy is like crystalline, but you get it wet, right? And it starts to like, I don't know, like dissolve and turn crystalline. That's kind of what those fibers do out in the UV. Okay, so think of it that way. All right. What are some, like we talked about, right? So your class ones, the double braids, 24 strand, even 32 strand, which we'll get into later. What is the material made of? You guys remember? Push-ups. You guys remember what it's made of? Nylon. Polyester. Okay. All right. So polyester cover. Nylon core is usually the material it's made of. Okay. What is the difference between a 24 strand double braid and a 32 strand double braid? Colin?
Someone said more strands.
Beautiful. More strands. Usually more strands. Yep. You're going to get performance characteristics differences, right? Usually they are less stretchy. Yeah, it's just strand count usually. Usually they're made of the same material, but you're going to get performance differences behind that. Okay. Kern mantle. What is the difference between a kern mantle rope, which I don't know who did it, but someone pulled out all of my strands, and now I just have this one rope left. So please don't pull out my samples. What's the difference between kern mantle and double braid? Mr. Daniel.
All the strands in the core are straight. They're braided.
They don't swing a little bit. Sorry, that was a dumb joke. That was a dumb joke. Yeah, so they're parallel, right? They're parallel fibers. They're not braided. The core is not braided. Okay. Kern mantle is not braided. So with that, right, we want a balanced rope. So if I have parallel fibers, okay, how do they keep it balanced? Okay, the strands are braided opposite each other. So you're going to have 6 one side, right hand twist, and 7 on the other side, or whatever. I think it's 12 or 6 and 6 on the other side. Cool. I can count, I swear. Yeah. Okay, cool. As far as equipment that we can use, life support, right? So foot ascenders, not life support. Hand ascenders that are holding us as part of our life support system. Can I use that on double braid and kern mantle ropes? A tooth cam ascender. That is part of my life support system. One. All right, so if I got a hand ascender, I got the Petzl Ascension. I think that's what it's called. Right, it's tooth cammed, and I'm using the tree frog system or the Texas tug. Right, it's going to hold me and keep me from falling in its tooth. Which rope can I not use that device on, and why? Mr. Josh? So I don't or do want to use it with kern mantle. Okay. Colin, you got a funny face. You're looking funny. Sorry. You still have a funny face, but.
I don't know. It seemed like the opposite.
Yeah. Dang. He knows me too well. Yeah, it's the opposite. Yeah, it's the opposite. Yeah. Okay. Why? You guys remember why?
Because a little pokey thing.
You'll break through the
Okay, hold on. What'd you say?
the spike in the centers versus the spike that grabs on.
Okay, so spike to spike. That's the key player into it, right? So if it's tooth cam, not a regular rigid cam or something like that, like your micro senders, okay? But it's about the construction of the core. Okay, so right, we have parallel fibers or we have braided fibers in the core. If I were to take a fall, right, as that fall comes down, we're not going to rip those fibers apart. Okay, it's just going to kind of slide down the core. Okay, that makes sense? We're tracking?
It's a hard one. I have no use for a hand to sit there.
That's good. It's good. Okay, I gave you guys some false information. I was double checking my stuff and I got it wrong. So fall factor, the load does not double. Okay. What it does is for every foot you fall, you multiply the feet times the load. Okay, so it doesn't double each time. I apologize for that, so I just want to clear that. So if I fall 3 feet and I weigh 150 pounds, how much force can I potentially put onto my system? Yeah, 450 pounds. Okay, so then it multiplies by that length of fall. Okay, so that's the peak load. That's what's talking about. So it was way above my pay grade as far as like the mathematical calculations and kinetic energy and E equals mc squared, and I fell asleep halfway through it. So I just know that you multiply the foot by the amount that's going to fall. So it doesn't compound. It's a linear kind of calculation. Okay. So just to clarify with that. All right. Okay. So what's next? We're going to talk mostly about today. We're going to get into 12 strand hollow braid. And your hollow braids, which is going to be a sling grade. So we're talking like 10x Tech, Trex. A lot of the HMPE and aramid fibers are going to be a 12 strand configuration. And some of the big differences behind that. And then we're going to walk into splices, rope splices, and the different types of splices that are out there. Sewn, hand, weaved, splice configurations, and the applications of different types of slings that are made out of different types of slices, okay? Or splices, not slices. So when I say 12 strand, right? 12 strand sling grade. So you guys have probably seen that in the G1 and G2 tests, okay? Where in our application, arboriculture, do we find 12 strand hollow braid slings? Slings. Slings. Got it? In slings. Yeah, okay. Okay, there. Cool. Everybody was looking at me like, I don't know. All right, so our dead eye slings are slings. Okay, so 12 strand hollow braid. So what that means is obviously it's got a hollow. Okay, so you could take it like a Chinese finger trap, bring it together, and you can weave your finger in there. Okay, and then now my finger's trapped. Okay, so hollow braid. Ooh, you like that? Come on. That was awkward. Sticking my finger in, you're all, ooh. Okay, so 12 strand, there's two different types. There's single and double plate. What that talks about is the lay of the strands. So you can see on this Trex, this 3/4 inch Trex, I have double plate here. That counts as one strand. These two together is how it's the way that it lays, okay? A single plate is going to be more like this, the Spectra. Okay, see how I only have one lay as opposed to two parallel fibers or strands going together. I just have one together. Okay, so this is still a 12 strand hollow braid, but it's going to be different as far as how many strands are within the lays, so it's a double plate. Okay.
What's the difference?
Okay, so this one, yeah. So two strands, right, that are woven,
Yeah.
single strands that are woven. Okay, so you have single double plate.
Why does that matter?
You can get more material. So if you add the double plate, you're going to get more material. You're going to get higher strength, better abrasion resistance, but you're losing the suppleness of it. So it's knotability, it's function around and going around things and tying things. Okay. So again, these are the characteristics that when the rope manufacturer thinks about what they want the rope to do in the specific application, they design it to perform in that area how they want it to do. So maybe these ones they want it to be able to be more supple, to run it through hardware or whatever the application is going to be, as opposed to this one they want more strands to be a little more rigid and firmness under load, or not firmness under load, but to be round under load. Okay, make sense? Okay. Why not? Right? Why not just use, like, why are we doing a hollow braid as opposed to just a regular 24 strand or 16 strand line? Right? Why would we just do 12 strand? Why not make slings? Right? Because I can put an eye in my 12 strand. I could put an eye in my class 2s and my double braids. What do you guys think? Mr. Anthony? Friction? No, not friction. Good guess though. Yeah. You didn't raise your hand when I'm calling you, Eric. Why would we use a 12 strand, this type of cordage, right, over a 24 strand? I can still put an eye in both. One is a little different, obviously, because it doesn't have a core. David? Okay, knotability. Yep. Okay, that's one. All right, so the biggest thing is going to be its spliceability. It's a lot easier to splice. Okay, so again, we have different constructions. We have performance about the same, but it's going to be the application where we can actually use that sling grade material. Okay, most of it's going to be polyester, is what they make it out of. So it's not going to be like a polyester nylon combination like our ionized were, right? They're a composite of Kevlar, polyesters, and aramid fibers that are in there, where they're kind of woven together for that heat shielding. They're just going to be a little easier to make, cheaper to make, but also easier to use and have different performance characteristics. Okay. Okay. Before we get too far, I want to talk about what's up on the TV. The elastic elongation, hysteresis, and then the permanent elongation. We'll touch on this real quick, and then I'm going to jump back into our slings real quick, and then we'll go into splices. So why, or no, not why, but the reason this topic is important is to understand the performance characteristics of your lines that you're using. So there is a point, right? So we talked about elongation last week, right? Polyester nylon have 12 to 15 or 15 to 28% elongation under load, whereas your aramids have like 4% and like 1.7% elongation. And we talked about why that was important as far as what we do in rigging and fall protection. But there is a point where there is a permanent elongation that the strands do not recover from. Okay, so ropes are designed to stretch, most of them. We want those characteristics. We want it to stretch, right? To slower load down, to give shock absorbance, and to limit the amount of dynamic loading that's happening, right? Other ones we don't want too much stretch because we want it to be solid and stiff, and we want to support, like boat anchors, or in our applications, crane slings. We don't want stretch when we're picking loads, logs and stuff like that, and landing it. Okay. But where we can run into problems is, so the ropes are designed with a working load limit. All right, so we talked about a few weeks ago the strength of the 24 strand, right? It's usually within 5,700 to 6,300 pounds. Those ropes are tested in a test bed for the break strength, but they're also tested for the elasticity and elongation, and that is 10% of the working load is where they'll get the elasticity. So when they're characterizing and building the ropes, those stretch performances are important. What they think about is the recoverable stretch. So if they know they put this arborist rope in, okay, and they have it rated for 5,400 pounds or 5,600 pounds, they know that safely you can put a repeated load onto this 560 pounds, which you want to do 10%, 560 pounds repeatedly under a safe fall factor, or not fall factor, but a working load limit. So that's where your working load limits is a percentage of the breaking strength of the lines. Okay. So they calculate the elongation within that. If you go above that, you end up putting 1,000 pounds on it, 1,500 pounds on it, which a lot of us have done that before. We've used some ropes and dumped some things onto it, like big logs, and well above the working load limit of those logs. What will happen is that rope cannot bring itself back together. So it's like a rubber band where you stretch it, right? And it's going to go back to its original size. But there's a point where if you keep stretching it, you start to get cracks or you start to get failure. And then now that rubber band is worn out quite a bit and gets all wobbly and not as stretchy anymore. You lose the stretchiness, okay? Why this is important to look out for is you're losing your elasticity and your elongation on that. So you're losing that, the shock absorption. Thank you. You're losing that shock. So now you're basically making your line into a more static line by doing that. You're also compromising the tensile strength of that rope because every time you use a rope, you're getting a lot of fibers that are breaking down and ripping. So when they're under load and they're constantly being, pulled, stretch, pull, stretch, pull, stretch, those fibers in there, those little small strands that are in there start to break and snap, and that's why ropes get fuzzy. You start to lose the strength of that rope. Okay, so you have elongation, which is its normal stretchiness of the rope. Okay, hysteresis is where it's been loaded, but over the course of time, that stretchiness can be recovered. Okay, what we want to look out for is the permanent elongation, to where we have overloaded the load. That's smart. The rope to the point where it cannot recover that stretchiness back. Okay, so you'll be able to notice that in a line, which I don't have currently, but it's stiff. So how many of you guys ever grabbed a rope and it's just some parts kind of like have some permanent bends in it, or it's like you can hold it out like a lightsaber and it just, it's super stiff and not as floppy as a normal rope is? That is what permanent elongation is. That rope has been overloaded past its working load limit. Okay, so if you notice that, especially in your climbing lines, your rigging lines, that is a key indicator of that rope being overloaded. Usually there's other, it can be debris or buildup or something like that, but that's a key indicator of that. Okay,
how would that happen like on a climb line unless you just fall all the
time?
Just
time, yeah, the constant loading, unloading, exposure to the elements will do that. Dirt, grit, and debris getting in there will cause that. But as far as like that overloading, that's not going to be in there. Usually on like climbing lines where the loads are really minimal, you're not going to see the permanent elongation. As far as that rigidness, it's usually going to be other elements that are in there, like dirt, grit, sap, are going to be in there causing that. But obviously in rigging lines, it's a different story. You can definitely see that real quickly. Okay. All right. Does that make sense? Cool. Okay. So, excuse me. Okay, so back. Sorry, little sidetrack there. Something I did want to cover as far as that elongation, and there was a good picture right here. So, right, new rope on the left, load applied. The 5 feet right there, that's the elastic elongation, and then total stretch was 10 feet. The hysteris was another 3 feet, and then that 2 feet at the end is that permanent elongation, to where that's not recoverable stretchy loss that was in there. Okay. All right. Okay, so back to 12 strand. So the reason why we use them as slings, one, they're easy to splice, they're easy to work with, they're supple, their softenability is really, really good and easy to use. And they're cheap to make is the biggest thing. So economically, they make sense, unless we're using, you've got your aramids, which are not cheap at all. Okay. All right. So any questions on constructions of ropes before we move into eye splices? Native? Okay. Good. Cool. We'll start off with this. What is the difference between an eye splice and a knot?
Not can
Okay, the knot can weaken the load or the strength of the rope. Correct? Yep. Okay. Why? An eye splice has got a bend in it. Tight ones. Okay.
The way it's terminated, since it's kind of like dispersed back into
Okay. Okay. Yep. So obviously knots, right? A way to make a connection point or an anchor point in a line. But there is always, anytime you put a bend in a rope, there is always strength loss in that. Always. Even under a slight deviation, you're always going to have a loss in strength. Okay. Who knows, like on average, I think we talked about this.
Candy love drinking.
You're right there, Dan? You're right?
trying to stretch.
Yes, I saw that. Thank you. That was entertaining. Cool. How much of the strength loss on average is, how much do we lose when we tie a knot into our rope? You guys remember from last year? Anybody want to take a stab at it?
One single bend,
A knot.
10%.
10%? Okay.
60%.
60 says Brian. What's that?
60.
60? Okay. Yep. So our running bowlines is a 60% reduction, or retains 60% of the strength of that line. So we have a 40% loss the second we tie a knot into our lines. Okay. So for easy numbers, right, we have a 6,000 tensile strength rope and I tie a bowline into it. I have a 40% loss. Okay. So that comes out to 4 times 6 is 24. So I have a 2,400 pound loss in my strength when I tie that knot into there. Okay. Why does that matter? Does that matter? Okay. Yep. Changes the whole load dynamics of the line, changes my working load limit now drops. Okay. So I have to take that in consideration. So if I know I got a brand new stable braid 1/2 inch line, okay, it's good for 10,000 pounds. And now I'm tying bowlines and clove hitches into it. Can I drop 1,000 pound logs on that? You're using the 10% rule of the working load limit. Can I drop 1,000 pound logs on that? No, I cannot, right? I need to reduce that and think about the whole entire system as a whole in my setup, right? Okay. So knots they're good, they're handy, they're quick. You can put them anywhere in the line, but they do reduce the strength significantly of the lines. So clever people came up with eye splices. Okay, there's many different types. Not all eye splices are the same. Each one is going to be differently. Obviously, with the 3-strand, you're going to have a 3-strand eye splice. The principle minus the sewn eyes, which technically is not a splice. Well, I wouldn't call it splice. I just call it sewn. Right? Is the principles off of that is off of the weaving and friction, and we'll get into that more. So 3-strand eye splice, super easy to do. It's a lot of fun. You can slap this in. I can braid this in about 2 minutes. Don't touch it, Mr. Will. You gonna use your impact today? I am now, you little turd. Yep. Okay. So I can really easy, right? So cheap as far as a 3-strand, but also easy to splice. Like I can cut this, pull the strands apart, weave it back together, and put an eye loop in that. Really handy to do. But there is, on all splices, there are specific ways to do these splices and how the process and the length that you use is incorporated into that. Okay? As you'll see as we get into the double braids, they get a little more complex. Okay, so basically, eye splices form a permanent loop or eye into the ropes for hard connections, as you guys know, everybody's seen them. But they have different performances, or yeah, performances, I want to say. Okay, all right. So 3-strand splice. I encourage you guys to come and take a look at this. The next one we'll talk about, because I don't like doing them and you're probably not going to see them that much, is 16-strand. Okay, so whereas this one, we pull apart the individual fibers and then we tuck and bury, tuck and bury, tuck and bury, tuck and bury, you know, and loop them around with the braid and the twist of the strands, right? This one's going to be a little different because it is balanced. What they do with the 16-strand eye splice is, so per diameter is 60 in centimeters, the length that you're going to use. Okay, so on 16-strand, what they'll do, first they'll figure out what the size of eye that they want. Okay, so they can make it, as big as you want. You find the size of that. All right, and then what you're going to do is you're going to make those marks, and then you're going to start taking that 60%, or not 60%, 60 times the length. Okay, and then you call what's tapering. Thank you. Gosh, brain, come on, brain. You taper the end. So there's a specific length that they do. Then they'll take that taper, which is all the way here, and then they run that with a fid all the way through the middle of the 16-strand. If it has a cord, that cord is removed for that section. And then they pull, and I sewed it here because I didn't want it going back out because it's a pain in the butt. And then from here, they pull that, and then they tuck in that portion of it until this last section is buried into there. Okay, that's all that is. So you'll find a nice taper. Basically the 6-strand goes in all the way through the cover, or the cover. Yeah, I guess it's called the cover, and then back out at a measured length, pulled, and then they form the eye on that. Okay. Yes.
Sorry, is that so the bend ratio? Say we can put a thimble in there. Is that still weaker than its straight rope?
No, it's actually the same.
Yeah.
So I'm going to fail you guys here, so I apologize. I don't, so this is what gets me about eye splices. So eye splices, you're putting a bend in the rope, right? But the rope strength is not lost. It's usually between 90 and 100%, depending on the splice, the strength of rope that is retained. A lot of times when they do testing, the eye splice stays and the failure point is within the middle part of the ropes. Why that is, because you are taking a bend over that, I have no idea. I just know that eye splices are just as strong as the ropes are. So I've looked for an explanation of that, because I'm like, well, maybe because it goes around the load, it splits it, right? So if I'm pulling 1,000 pounds, 500s on this side, 500s on that side, and maybe it shares the load behind that. But other than that, I have no explanation why. The reason why knots reduce that is because there's multiple bends in there and they start to bend and twist on each other, and they're not sharing the load in that aspect. And then you get heat and friction build up that actually degrades the line, and then you get failure behind that. So, yep. Okay. That answer your question? Kind of, maybe? Okay. All right. So that's 16 strand I-splice. So what they do, so after they tuck those in, right, they form the eye that they want, they're going to do what's called a lock stitch or a whip. The purpose of the whip, I had one. Where'd it go? You stole my whip? Well, anyway. So looks like this. So this is on a 24 strand, but it's the same thing. So it's a whip. So they'll take whipping twine. It's a smaller line. They'll wrap it around where the berry was in. They'll wrap it around, run the needle through, and the only purpose of that whip is not for strength, it's to keep that from working itself back out. So when these constantly get loaded and unloaded, right, load, unload, load, unload, this splice can actually work itself back out. So that whip is just there when it's unloaded and loaded. It doesn't cause the creeping for that I-splice to come back out. If you're, well, we'll get into that later. Okay. Any questions on 16? Okay, 24 strand. A little more difficult of a I-splice. So instead of 16 strand, normally the core is not part of the load, right? So we have, in a sense, a hollow braid. Okay, so they can bury that in and use friction. So it's unloaded, it grabs around itself and keeps that splice from coming out. We can't really do that with a double braid. Okay, so what they do, same concept, right? You measure out the size of the eye that you want. You want a tight eye, you want a bigger I-splice. Like these ones, well, this is a different one, but we'll, anyway, okay? So they measure it out. Then what they do is they take the core, they pull that core out, they taper that core, they bury it back in, okay? And this is a sample, you guys can come and look at it. They do what's called the crossover. So the core at this point goes into the cover goes into the core at this point. The cover is tapered, as you can see here. Those tapers, and then this is milked back out. So here, right at that transition, the core goes into the cover. This gets milked back out, and this is all specific to the size and diameter of the rope. It'll be a fit, several fid lengths, and a fit is what they use to put the rope into that. This will cover the core completely. Okay, so it's going to look like that, but inside here, because this is almost like hollow, inside there is going to be the core, the cover that's inside the core. And then they milk this to the point to where they draw that back into itself. Okay, so as this gets milked back into its exit point, okay, as this gets pulled, the other end gets pulled, this will eventually get buried inside there. Okay, it'll look like that. Okay, so right about in this area is going to be that transition point where the cover goes into the core, and then that's buried and tapered. Okay, so a little more time, labor intensive. There's a lot of tapering, cutting behind that. So as you fill your I-splice right past that, usually you fill a taper towards the end, and then that I-splice usually ends, several inches down below to where that berry is. Okay, same thing as the 16 strand. They're going to have whipping on it or a lock stitch. So the whipping is going to be wrapped around tight and then shoved in, and that's the same concept where as this is loaded, unloaded, you could actually take your I-splice and work it back out. Oops, that one a little far. I'm not getting that back in. All right, that one's done. We'll keep like that for show and tell. So right there's a crossover. Okay, so this is the cover. This is the double braided core. And then this is the lock stitch that was cut or damaged. As you can see, that just got pulled out. Okay. So that's a double braid class 1 I-splice. The class 2 is going to be different. All right. So since it is core dependent, I don't want to incorporate the cover right into my splice because the cover is not part of the loading process. Okay. So what they do is instead of pulling the cover out or the core out, doing the crossover, tapering everything, putting it back in, they'll form their eye, how big they want it. They'll pull out, they'll measure past a little bit, and then they'll pull out the core after that. And the core, they're basically just going to bury that back in with the taper, just like with the 16 strand. Okay, so that's going to go back into the core itself. And then this one runs down to there. So that's the splice.
Wherever you're thinking, how's that not a weak spot? Wrap my head around that.
Well, what do you mean? Right? Yeah, because right here is the end.
Yeah.
That's technically the end of the rope, right? So, and this is a good question. That's where that friction comes into play. Okay. So the reason why this doesn't come out as it's loaded, it's like a Chinese finger trap, right? It's grabbing around. So the friction, why this one's so long, is because when it's pulled, this is crimping around itself, not allowing that splice to come out. Okay. That makes sense?
Yeah.
Okay. So that's class 2. If you have questions on the biggest indicator between the two on which one it is, and this is a key indicator what type of rope you have, if it is a class 1 or a class 2, is going to be, if it has a splice, you can run your hand down and be like, oh, that's long. That's got to be a class 2. Okay. Especially if it's that length. You have a class 1, usually it's only, minus that there, usually it's only about that length. A class 2 is going to have a longer rope splice onto that. Okay. Cool. That is the same when we get into 12 strand eye splices. There are the same concept. So the class 2 splice is going to be the same concept for your hollow braids as well. Okay. So on this one, this is a class 2 eye splice. This is Kevlar. This is an aramid fiber. All it is the measure out the length of, the 60 times the diameter of it, and that's the length that you get that you want to pull out. So right here, this is pulled out. You pull, or you wrap it back in, bury it back into itself, run it down, and then provide the taper for the rope at the end. That is all that is holding this ring from coming out, is that friction. And then you'll lock stitch it, right, like I have here, to keep that from working itself back out. Okay. So normally in our industry, you're not going to see a class 2 eye splice, especially in hardware. They're pretty rare except for cranes. But it's good to share the differences behind it. What you guys are going to see a lot, especially in 12 strand hollow braids, is called the Locked Brummel. Okay. This is you're going to see a lot of these in your crane slings. Okay. So the Locked Brummel is super simple. Okay. What they do, right, you measure out your eye that you want. Okay. And then as you can see, we kind of have some funkiness going on here. I wish I had a separate piece. Okay, so here. Right, so same kind of stuff, right? So I have an end. I'm going to form the eye size that I want. Okay. You measure out the specific length according to the diameter of the line. And then you're going to take the end, and then you're going to run it through itself, through the middle of the berry. Okay. So it's ran through it. So normally, people who don't educate themselves on it, they're just going to go like this and think, I'm going to run that back through the other way. Okay. And then I'm going to run this down the middle and bury it. Okay. Which is, it's going to end up looking like this. Okay. What will happen if you do that is you don't have like the class 2s. Okay. So if I did that, see how this can slide in and out? There's nothing locking that in. So what they'll do, why it's called the Locked Brummel, and what keeps this from coming in and out is after, right, so that one went in. After that, they take the other end of the rope and then they run it through the working end of the line, and then they lock it in. So now I can pull one side or the other, and this one is not coming out at all unless I take the entire other end and pull this all the way out. Then I'd be able to pull that berry out. Okay, so that's why they call it Locked Brummel, because there's no way, especially in a load, that this is going to come out. After that, to make it clean, they'll taper the end, and then they'll run this through 2 picks down through the middle. Okay, and that's where you're going to get it to where it kind of hides and keeps it clean. Not so much on this part, that's the tail end. Okay, so then it's going to run in. That's maybe a better example. Okay, then they'll bury it back in and then run that out and taper that out. All right, so same thing with the double braids and the class 2s. They're going to do a lock stitch or a whip that's going to keep that from the end working itself out. If you have a 12 strand splice sling and the whip is missing, it is not defective. Okay, you might be able to pull the berry out of that, but it's not compromising the integrity of the splice itself. It will reduce it because at this transition point, you will get different strand loadings. So obviously we can rebury that and refix that if it does come back out. But just so you guys know, if it's missing that lock stitch in there, the sling's not defective on the Locked Brummel. Okay. All right, does that make sense? Anybody are you tracking? Okay. I really want, yeah, let's get this done because I want to go into something else next week. So, okay. So with that, we have different types of configurations of slings that we can get into. These are models. This, just for example, is what I did. So we have an ultra sling. Okay, so it's the one with the pockets. This came out, 7-8 years ago, maybe a little longer than that. Pretty nifty line. This is knotless rigging. Okay, so what you can do is run those in those pockets, and it chokes around there, and now I've got a secure anchor point for that. So that's an ultra sling. Okay, we'll go into deeper into this when we get into the rigging side of things, but this is just for the splice side. All those is just a bunch of locked brummels that run down the line there. Okay, you have a loopy sling. So this is different from the whoopee sling. The whoopee sling has berries. There's technically not a splice in there. What they do is, based off of the rope's diameter, they run it through, kind of the same concept of the class 2 splice, where that runs down the whole length, and they use friction to keep that from coming out. That is the same with the loopy sling. Okay, so what it is now, I can adjust the length of it, and then because the Chinese finger trap, right, that's not going to go anywhere. So now I can set this and then girth hitch it around my anchor point. So another knotless rigging. Okay. The downfall of this one is there isn't an splice on that. So if I have to have something to choke on the end of this, like a porter wrap, if I want to girth hitch it on there, I can't do that because it's going to cause uneven loading of that. So I need something that's going to have, and normally you have something here to keep the pinching. Normally I have something in there that can move and slide around. So you can put a fixed cheek plate pulley on it, or you can use a regular block in there, and you put that in there. That can slide around. So we'll go in more detail when we get into the rigging side and application stuff. I just want to demonstrate the different types of splices. Okay, so loopy, and then you'll get into a whoopee. Okay, so the big difference is, so a loopy is a continuous loop, and then the two ends have a tuck and bury on that, right? So they just take the other end of the splice, run it back through to keep that from unfraying on itself, and then also on this acts as a stopper to keep you from pulling that all the way out through. Okay, it's like a stopper knot basically. So the whoopee, the big key difference is the whoopee is going to have an splice on the end of it. Okay, that isn't a section that you can terminate and girth hitch like a porter wrap onto it or a block. Don't girth hitch the block, but you put the block in the splice part. Okay, so you'll see a Locked Brummel that's got the bury, And then you have after that, after buried, then you have your loop. So the biggest difference, okay, one's a loop and then one's a whoopee. Okay, both can be adjusted and work off the same concept of I adjust the length that I need, right? And then I can run this around a limb or log and do the configuration on that, okay? Everybody understand the difference between the two? Okay. Loopy slings are awesome to work with, quick and easy, knotless rigging. Yeah, we'll go into that stuff when we get into correct, right? So loopy, so think of like it's a continuous loop and it doesn't have that dead eye on it, okay? The whoopee, the Goldberg, okay, is in a line usually straight, okay? And it's going to have a eye splice. That's the key thing. It's going to have an eye splice on one of the ends. And to make sure, for a while there, I forget who came out with their splice. They spliced it wrong. They do a recall. They had the whoopee going this way, and so when it was loaded, right, it wasn't in line. This was on the other end, and it was causing the rope to be ripped out. So bad. So anyway, we don't have those anymore. Okay, so those are. And that's why 12 strand is awesome. You can do a lot of different configurations and things with them, and their applications are really easy to put into there. So, any questions on eye splices? Sorry, I ran through that really quick, but we didn't have a lot of time. So, okay, everyone understand the difference between a loopy and a whoopee? Cool. Everyone understands where Locked Brummel is? Yep. Okay. All right, yeah, cool. That's it. Yeah, next week we're going to go to rope inspection and how to inspect your ropes, and then get into hardware, markings, identifications, inspections, and applications. Okay, cool. All right, well, hey, that's all I got, guys. Let's wrap up.